Namastey Coders, I hope you're fine, doing well in your life. So now we are gonna start with the LeetCode 75 question series, and we are gonna solve the second problem of binary search. So we have solved the first problem of every topic, and we have solved the second problem till heap. I have uploaded the video. You can check out the video in the playlist, right? Along with this LeetCode 75 questions, I have started solving LeetCode problem of the day. The playlist link is given in the description box. Okay, so let's start with the problem. So problem is successful pair of spells and portions. So before starting the problem, I have something to tell you, that I have created a WhatsApp group for the coders, right? So if you want to be a part of a good community of coders, you can join the WhatsApp group. The link is given in the description box. So there are multiple benefits of a community, right? So if we can build a good community, that will gonna help all of us, right? Not only me, but all of us. Okay, so I suggest you to join the WhatsApp group. It's completely free, and link is given in the description box. So let's start with the video. Let's start with the problem. So I will gonna solve this problem in 3 steps. First, I will discuss the details. Okay, then I will discuss the native approach. Then after that, I will discuss the optimized one. So this is the similar pattern of the interviews. In the interview, so the interviewer will expect you to solve the problem in the similar way. So the problem is successful pair of spells and portions. This is the problem from binary search, and you are given two positive integers array, spell and portion of length n and m respectively, where spells I represent the strength of ith spell and position represents the strength of jth position. You are also given an integer success. A spell and a position pair is considered successful if the product of their strength is at least success. Okay, return integer array pairs of length n, where pair I is the number of positions that will form a successful pair with ith spell. So we have given two arrays. First is spells and second is positions. Okay, and we have given a variable success, right? So what we have to find is, we have to find that how many positions will get success with spell 5, right? So we can check that if 5 into 1, right, product, right, we have to find the product. So 5 into 1 is greater than 7, so no. 5 into 2 is greater than 7, yes. And then similarly 5 comma 3 will make a pair, 5 comma 4 will make a pair, and 5 comma 5 will make a pair. For 5 comma 1 will not make a pair. So there are 4 pairs which can be made with this spell. So for this spell, answer is 4. With 1, answer is 0, because there is no position which can make a pair with 1, because 7 is the success rate, is the success criteria. So 0 is the answer for 1. And similarly for 3 comma 2 cannot make a pair, but 3 comma 3 can make a pair. So 3 is the answer, right? 3 means these 3 positions can make a pair. This 3. So this is the problem, and let's discuss how can we solve this, right? So the native is a straightforward approach, in which what we can do, we can iterate through this spell, and for each spell we can iterate through every portion, and can check that if that spell can make a pair with that portion, and if yes, we can increase our count for that spell, and then we will append that count in the answer, right? So we can do this job in n cross m time complexity, which is yeah, we can optimize this. So we can solve this problem in native approach with n cross n time complexity, right? but we have to do it in the better time complexity, because that's what a programmer is supposed to do, right? We have to optimize our programs. So what we can do, we can use something called binary search. How can we use binary search? You can ask that, okay, Kana, binary search is gonna applied on the sorted arrays only, right? So no problem, we can sort this array. This sorting will cost me n, so m, right? M log m, which is still very less than n cross m, right? So I will prefer this anytime. Okay, so this is not just m log m, there are multiple other operations also, the operations of binary search. Okay, so binary search will gonna we're gonna do in log m. So the total time complexity will become m log square m, which is again smaller than this, right? So yes, this is getting optimized, right? Because we are reducing our time complexity. This is again very smaller than m cross n. Okay, so log square will take us like this, and n cross m will take us like this, which is very high. Okay, so how can we solve in this? How can we use binary search? So I hope that you are aware of upper bound, lower bound. But if you are not aware, let me tell you that what is upper bound and what is lower bound. So the upper bound is a technique in which we can find the upper bound of any element in the sorted array. Upper bound and lower bound means, so the upper bound is, so the lower bound is the first presence of the element, or so the first presence of the element. If element is not present, it will return the greater element, right? And lower bound will always return the greater element. So upper bound is always written this, lower bound will return 6, this if 6 is present. If 6 is not present, this will return greater element. Okay, and if element is not present, right? If element is not present, this will return this. Okay, so if we have given 0, this will return 1, both upper bound and lower bound, because 0 is not present and 0 is smaller than every element. So the next greater element then 0 is 1. So upper bound will return 1, lower bound will return 1. We have asked 2. Lower bound will return 2 because 2 is present, but upper bound will return next greater element. So upper bound will return 3. If we will ask 12, both upper bound and lower bound will return 11 because they will return next the last element if the given element is greater than the last element, right? So this is what upper bound and lower bound. This is the implementation of our lower bound. This is the implementation of upper bound. If you want, we can discuss it in some other video. Okay, so I have implemented upper bound here. So what I'm doing is I've sorted the portion array, right? I've created the answer array. Now for every spell, I will check that what is the what is the lower bound of that, right? And if L is the last element, right? That means I have to again check that if, because as I've said here, right? If the target element is greater than all the elements in the array, it will return the last element. So we don't want last element in that case. So I'm checking that here. If L is the last element, portion.size minus L is indicating as the last element. That means we have to check that if target is greater than that element or not. So if success is the target, success is greater than, right? That means the success is not present in the whole array. So we cannot. So this is not gonna be added, right? So we will return. We will increase our L. Means L will point here. Means out of the bound, right? And then we will add portion dot size minus L, right? That means if we found 6 here, so we know that these 4 elements will gonna make my pair with that spell, right? So I will add these element in the answer. And how I'm finding these lower bound, upper bound, I'm using the technique of finding lower bound, right? So this is the implementation of lower bound. This is the similar kind of a thing as a binary search. If you can see, I am using a mid and I am using a divide and conquer rule, right? So if my target is greater, my start will point to the mid of next of the mid, otherwise my end will point to the mid, right? So this is how we are gonna find the lower bound. And for upper bound, we have to just add one equal here. If I will add this, so this will the implementation of upper bound, right? So this is the implementation of this problem. This is the solution of this problem. If you can see, I've solved this problem with 15% time complexity. It's still good because you can see this is the 25 ms and this is the 45 ms, which is okay, right? This is not an exponential case. This is the linear, right? This is due to some constants, nothing else. My time complexity is still best, right? Okay, so this is the implementation, this is the solution. Thank you guys, thank you for your time. That's all from my side in this video. If you have any suggestion for me, you can directly share in the comment section. I will really appreciate that. And also I again suggest you all to join the WhatsApp group. That will be beneficial for all of us. So thank you, have a nice day.